Hello, this is Scott Dahman of PowerWorld Corporation. In this session, we'll take a look at how auxiliary files and the SimAuto tool can be used to automate analysis and simplify tasks in PowerWorld Simulator. One, we'll look at just some applications of using auxiliary files to standardize settings. And this is pretty handy if you're working with raw files a lot of times, where your settings for things that you like to look at with area zone filters and limit monitoring settings that you like to use, they're not in the raw file format, but you end up applying the same settings every time you do some analysis. It would be a very good idea to put those in auxiliary files, because then you don't have to go through all the menus every time, and then also you reduce the chance that you're accidentally going to forget something or make a mistake. In the second part of this section, we'll take a look at a SimAuto application that runs on Microsoft Access for doing nodal market simulations in an hourly format, where the load is changing every hour and possibly the generation unit commitment changes as well. And we'll just look at an example with that. So first off, using auxiliary files to standardize things. Some benefits of doing this, like I mentioned, quality assurance. You're not going to accidentally forget something. A lot of the menus in Simulator, have lots of buttons and checkboxes and things like that. And if you're just trying to remember that, oh yeah, I like to check this box and set this button to this setting, doing it manually not only takes time, but you might forget something. So much easier just to make those settings one time, save them to an auxiliary file, and then load them. So you can customize the environment, things like area zone filters, things like display grids, what fields you like to see with different displays in the Model Explorer. You put that in an auxiliary file, and then you don't have to make those changes manually each time. If you do some parts of a study and you've got certain settings that you set up and you want to make it reproducible or show what you've done to a manager or to a client, if that manager or client also works in PowerWorld Simulator, you can put all your settings and all your assumptions in there, and then they can go through and see exactly what you did. You can document the whole process and what you did from original raw file to the results that you generated. Certainly automation is useful too. If there's something that you're repeating a lot, a process that you're repeating, if you put it in an auxiliary file, you can save a lot of mouse clicks. There's also an auxiliary file format for one-line diagrams. It's a text file format, just like the auxiliary file, and it can be used to describe features and objects on a one-line diagram. So you could programmatically generate one of these and then create or modify a one-line diagram with the text file. Okay, so standardizing settings, common things certainly that I like to use auxiliary files for are doing my solution options, limit monitoring settings, contingency options, things like that. I mean, a lot of times you're using the same settings over and over again. So just loading them from an auxiliary file is much easier than opening a menu. We'll do an example with a set of files on the eastern.pwb case. So I'll switch over to Simulator and go to the file and choose eastern.pwb. And I'll also open the auxiliary files, or some of them at least, in a text file editor here to just show what's going on. So this particular file right here is an auxiliary file that loads other auxiliary files. And as we'll see, that's a powerful approach in a few different ways. It loads separate files for things like solution options, limit monitoring, OPF options, and so forth. So if I examine that file, I'll go up here to load it, and then I'll simply open it in a text file editor. I'll right click on here and then choose edit. So there's a bunch of comments at the top of the file, which just I use for documentation. It's a single script section in the auxiliary file, and then inside the script section are statements, loadaux statements, and so they load different files. And the advantages to this approach, which I like, is that you can see an overview of the whole process. Also, if things change over time, like for example here we have a file that loads some filters and custom expressions. We have another file that has solution options in it. Maybe you're using one set of options right now, but down the road you want to change some of these features. Let's say we're going to continue to keep our existing filters and expressions and our solution options, but our limit monitoring settings are going to change that we want to use for the next study or something like that. Then you can just go and replace this file or edit this file with a new set of settings, and it doesn't affect the rest of the settings that are not related to that. So it's much easier. If you put everything in a single auxiliary file, then you're left with, in order to maintain them, you're left with needing to open that file and cut out pieces that you don't need anymore and insert pieces that you do need. And so if you have different files for different categories of settings, you can simply just replace that file with a new file, and then everything else stays the same. Another thing that you can do is you can just add the comment string to the beginning of a line. So for example, maybe all these settings I use commonly, but in the next phase of a study or the next study I don't need a contingency analysis file, or maybe I need a different contingency analysis file. You can just go in and comment out the loadaux statement for that file and then just temporarily skip it, and then when you want to come back and use it again, you can remove the comment string, and the next time you load it, it'll be used. So a lot of advantages to the method of using a master auxiliary file to load other auxiliary files. Okay, so this just shows the text that was in that master file inside the script section. And again, these are the advantages to using that approach. Also, by using the loadaux command in there, you can suppress confirmation dialogues. So you might notice a lot of times when we load auxiliary files, if you are creating new objects, then you'll get a confirmation dialog in Simulator that says, do you want to create the new objects? And you can say yes, no, yes to all, no to all. If you've got a set of files that you've created and you always know that you want to click yes to all on those confirmation dialogues, you can simply put the yes argument right here in the loadaux file, and that'll just suppress that dialog. So you don't have to, when you're loading a bunch of settings, you don't have to constantly click on confirmation dialogues. It's also useful if within the file, if you do things like using script actions to select all, change the selected objects, and then unselect all. For example, let's say you've got a large case and your study area is only 10 different areas within that case, and it's something that you keep studying the same 10 areas over time. The base cases that you're using might change over time, and maybe there's the set of external areas that you're not studying. Maybe there's some changes too, like next year a particular area in another part of the system is being broken into 2 areas or something like that, but your study area doesn't change. If you have an auxiliary file that lists all of the areas and makes the settings for all of them, then it might not work well when new areas pop in the future. But if you're just initializing the settings for all the areas, like for example with area zone filters, you can tell it to not show all of the areas and then just go back and then show the areas that you care about that are in your study system. Then you just need to maintain the records for your study system. You don't need to maintain records for the entire case. It helps with the compatibility of your auxiliary file. And it's good to know that the selected field is available for every object, and it's also not saved with a case when you save the PWB, so it's always initialized to know when a new case is open. If you're working with the selected field, you still might want to initialize it either to yes or no. when you're doing stuff. So let's, like, for example, let's look at our limit monitoring settings here. If I look at the auxiliary file, it contains my limit monitoring settings. I'll see it has some features in it where it selects all the areas in the case, and then it sets the report limits field to no. So it's initializing all the areas to not monitor, and then it uses a filter which is loaded previously in the master script. It loads this filters and expression file, and then it references a filter called study system, and that filter identifies the areas that I care about, and it sets their report limits field to yes. So I don't need to worry about all of the areas that are outside my study system, because it's going to open the case and it's going to not monitor any of them and then just flip back to yes, the ones that I care about. So I only need to maintain going forward the definition of the study system filter. I don't need to maintain anything else as far as setting up my limit monitoring settings. So that's a good tip as well. So, and then you can also start, you don't have to create an auxiliary file by typing everything in. You might start with saving something out of a case info display and then going in and tweaking it with a text editor. So, of course, as we've reviewed in some of the other sections, there's lots of ways you can create auxiliary files from the Model Explorer and a case information display in the Model Explorer. You can take any one of these and you can right click and save the display as an auxiliary file. Of course, you got to know if you use that option, then it's going to save out everything that's in the display and nothing that's not in the display. So you want to make sure that you have the fields and the records, only the ones that you want to save into the auxiliary file, and nothing extra and nothing missing. Of course, you can also just make a partial selection and save just the selected records or only the selected records and columns as well. But a lot of times it's good just to make your display show everything that you want stored in that file. And then you can also build auxiliary files by saving something out from a display, going to a different display, and appending it to a file that you've already started. You can add script sections if needed. If you're dumping a bunch of data sections out from the files, you might go back and add some script sections. And then also, just about every dialog in Simulator has a button for saving to auxiliary files. So for example, if we look at our Simulator options, so you come in here, and of course there's all kinds of options in this dialog. Pages that are nested within pages. We've got the PowerFlow solution options, all these pages, one-line options, all these. You go through here, you make the selections you want, you check the boxes you want, you put values in other cells that you want, and you can save this then to an auxiliary file by just, after you make your settings, come down here, click Save to Aux, and then create a file for it. And then, next time you want to impart those settings on a case, you just load that file back. You don't have to remember which boxes you clicked on and which buttons you selected and what value you changed all these numbers to. So that's very helpful. Yeah, and again, don't include extra fields when you save stuff out to a data section is a good tip. Like for example, if you want a file that sets the AGC status for a bunch of generators, don't include in the data that you save out to the auxiliary file the generator megawatts, because the next case that you work in, you might not want those values for generator megawatts. If you want to set the AGC, save out the key fields and the AGC status and none of the other fields. So, and of course, you can use comments once you create things. Okay, so next we'll look at an example of the auxiliary file format that pertains to one-line diagrams. And those files have the extension of AXD, the D for display. And it just extends a lot of the functionality of auxiliary files to one-line diagrams. So you can also see case information displays of one-line diagrams if you have a diagram selected, like this one right here, and we go to the One Lines tab, we can go to the Display Explorer right here, the List Display. Click on that, and then, for example, we could choose All Display Objects. And this opens up a window that looks very much like the Model Explorer, except what you see in here are descriptions of the display objects. So there's one display that shows everything and some summary information about it, like buses, and then there's groupings, just like there is in the Model Explorer, for network aggregations and other things like that. So for example, I could look at buses. This shows that there's 536 bus objects drawn on the display, and the characteristics are described here in text format. So for example, the bus number, where it's positioned on the diagram in XY coordinates or latitude longitude coordinates, how thick it is, the color, and you can actually edit stuff in here too. If I want to change the thickness of this bus on the one line diagram, I can just put a new value in there and it'll change the one line diagram. I can change the color as well, and just these other properties, size, etc., orientation. So, and then you can also load this information in from a display auxiliary file. One thing you'll notice is that about the objects that are on the display, they generally have the same key fields as the underlying objects does, but with one extra field appended to the key, the auxiliary ID. And this is because on a one-line diagram, you can represent the same object as many times as you want. I mean, normally you would have a bus. If you have a bus diagram, you would draw a bus at most one time on that diagram, but there's nothing that prevents you from doing that. So if you wanted to put a bus in two different locations, maybe have it in two different views or something like that, then you could do that, and each instance of that bus would have a unique auxiliary ID. So that's just part of the key. It's another field that gets appended to every object. I can see at generators here, I see the bus number, the generator ID, and then the auxiliary ID. So that's in there too. And with this example right here, we'll load a display auxiliary file that alters the routing of transmission lines. So we can do that from here, or we can also do it by right-clicking on the one-line diagram as well. So I just right-clicked in the grid. First I'll just open it and show you what it looks like. And it's in the M9 subdirectory. It's called easternlinerouting.axd. So I'll just open this in a text editor. And again, it looks very much like the data section that you would see for the case information, but the object types are different. So here's the object type display transmission line, and it has the key fields for the transmission line in here, which are all the key fields for the line objects, as well as the auxiliary ID. So, and then it also has a color field and then some comments in here. So there's really just two records in here with a bunch of subdata. So this references one transmission line between bus 479 and 75406, circuit ID 1, auxiliary display ID 1, and it sets the color to 255, which I believe is red. And then as subdata, there are a bunch of vertices for the line. So those get loaded as well, and it will change the routing of the line. And then there's a second record as I scroll down here for a different line with similar information. So I'll close that. And what I'll do is I'll just load this from the one line display so we can kind of see the change being made. So it's these two transmission lines right here. So they have they're drawn on the one line diagram in one way. And then if I load that display auxiliary file, again in the M9 subdirectory here, it'll change the routing of those two lines. The display auxiliary file format then, is kind of powerful, because you can either add objects to a diagram or modify ones that are in there using a text file, which could be programmatically generated. So if you have data, for example, on line routings in some external database, you could program that external database to generate a display auxiliary file that you can then load into a one-line diagram to either draw or modify the objects on that one-line diagram. So, and again, here's a kind of before and after as we loaded that file. And again, you can look at things in the Display Explorer. You can export, the information in here. You can save it to an AXD file, just like you can with the case objects from the Model Explorer. All right, lastly, we'll look at a SimAuto application that does an hourly simulation in Power World Simulator. So this example application runs on Microsoft Access. In order to load it, you either need to have Access, or you can also download, I think, a free runtime program which would allow you to run applications, but it would be harder to edit them. You wouldn't be able to edit them directly in there. So this works on Access. The application has a main form that we'll see when we open it that allows you to put some data in there that gets sent into Simulator. And then the process is done where it solves an optimal power flow for each time point that you send in. It sends some other parameters in, like load schedules, outputs of certain generators, like, for example, wind and solar, maybe fixed generators. Use the application to do that. Of course, you could code your own application to do even much more than that. This is really just an example. It also loads some other auxiliary files. So these are the inputs that you specify on the form are what file to use. So it's a PWB file that it points to. It points to an auxiliary file with some settings that get loaded later. There's information in the database with loads, information with megawatt outputs for some generation that is not dispatchable in the OPF. And then some other settings, like maybe maybe generator bids change with different time points. So those auxiliary files can be specified. You can also put in a fixed bid for hydro units if you want on the form. And then the process that it goes through is it'll solve each hourly time point. At each hourly time point, it'll push data into Simulator from the database, solve the optimal power flow, and then retrieve some fields. There's just a couple fields that get retrieved: the megawatt dispatch for each generator and the LMP at each generator's terminal bus. Okay, so I'll go ahead and open it. These slides just describe some features of the user interface, which is just a form in Microsoft Access. So the example is inside training cases directory, M9 OPF Automation, and then there's another subdirectory under there called SimAuto. There's two database files, one with data and one with code in it, and the code lives in the one called OPF Automation Forms. So I'll open that, and it opens this form in Access, and there's different records down here with different parameters. So this is just a description for my information. This is not going to get passed into Simulator in any way. It's just a descriptor. There's the name of a case. I'll go back to the first record and we'll do this one. So this one's called the base scenario. It runs on the b7.opf case. Before it does any of the simulation, it loads in the settings. It loads in this auxiliary file. So that auxiliary file can contain whatever you want. If you want to, this is the name of an advanced filter for what generator records to retrieve for results. In the 7-bus case, it's small, so I'll just retrieve results for everything. But if you wanted to use this example to build on, and you're working with larger cases, then you would want perhaps to have a filter in here so you're not retrieving results for every single generator in the case, but only for a study footprint that you're interested in. There's different scenarios, and I can see in this drop down you can have for wind forecast fixed generation, so that's generation that's not dispatchable by the OPF, and then same thing for loads. So, and then there's some buttons over here. So if I click the fixed generation button, these are the inputs that are going to get passed into simulator for these generators. This is for generator at bus 1, ID 1, different megawatt values for each time period. And it might be useful, when we run SimAuto, we don't have a graphical user interface. It's going to start an instance of simulator in the background, but we might also want to just kind of manually look at one of these cases too. So these are cases that get saved, which we'll take a look at later. But so again, this is just the 7-bus case that we've worked in. The fuel types are set in here. So for example, this generator up here at bus 1 is modeled as a wind turbine. So, and then we have thermal units at bus 2, 4, and 6, and a hydro unit at bus 7. The code treats them differently. For the wind unit, we're going to tell it each hour what we want its output to be. So that's shown in there. There's also in the database a load schedule. So I can click that, and I can see for each area and for each time point it's got megawatt value. That gets passed in by the SimAuto routine before it solves the optimal power flow for each hour. It tells it to scale the load to those values. And then there's also a set of auxiliary files that get loaded. In this case, we've got 5 different auxiliary files with different cost models in them, and they have different effective dates. So as it's going through the simulation, it'll load the files at the appropriate time. And you can tell it down here for the hydro units in the case, if you want those to be bid at a fixed value, you can do that. So, and then you can tell it down here when to start and when to finish. So if we click the button for running OPF simulation, then that goes ahead and launches it. And I can probably open my task manager right here and see that there's a background process for Power World Simulator. And that's shown right here. So, and then there's a log down here. It's just reporting as it goes through the whole process what step it's at. And then when it's done, then that background process is closed. So it goes away. So now there's a button in here for viewing results, and I can click that, and I can see, like, for each time point and for each of the 5 generators in the case, the one at bus 1, 2, 4, 6, and 7, what its output was and what the megawatt marginal cost was. So there aren't any fancy graphing or visualization tools, but certainly if you had an application like this and you wanted to make one, you could do that if you wanted to. But I can see here, again, for each time point, how the dispatch is changing, and then how the megawatt marginal price is changing. And there's a button here for archive solution cases. If you check that, then what it does is it creates a case, it saves a PWB file. And that's what all these files are right here. So if I open, and the file name is coded with the time and the corresponding time point that it solved. So if I want to grab this one here at like 2 p.m., then I can explore the solution that it came to. So here's the OPF solution, how my generation is dispatched, what my loads are, and so forth. So I can go in and, by saving the PWB at each time, if I want to manually, explore it later, I can do that. I could go into my, OPF options and results and see it has the, solution summary. I can look at the basis matrix, etc. I can look at my binding constraints. You can look at all the data. So, and then if you wanted to explore, what's behind all this, in Microsoft Access, you can go just open the Visual Basic from the Database Tools ribbon. You can open that, and then you can see the code in there. The main button is the Run OPF Simulation button, and so that object has a name called Run OPF button. And if you go to that, then you can see what happens when you just click on it. There's another procedure that's in here that you can browse called Get Simulation Parameters. So what that's going to do is it's going to look at the values that are in each of these fields, in each of these boxes, so it knows what those are. There's a procedure for launching SimAuto, and the SimAuto object is then called MySimAuto. So there's an outer loop right here that basically just checks and makes sure that it was able to launch SimAuto. If SimAuto doesn't exist, that the loop is over and it doesn't do anything more. But if it does exist, if it's not equal to nothing, then it goes through and does this. So this is, there's comments in here. It tells you that it's doing some things in the message log object, and then it's doing some other things in here. These are all procedures right here. And for example, there's a procedure called load made main aux file. If I wanted to explore that, I can come up here to general and then load main aux file. So it's using the SimAuto command process aux file, and it's getting the name of that file from some other list in the database. So I don't remember all the details about exactly all the loops and things that are going on in here, but you can see it's using that function. There's another part where it's running the simulation, and it's got a loop to go through all the different time points, and it calls other functions to load auxiliary files, calls a function for setting generator outputs, and so forth. Here's where it's actually solving the optimal power flow inside this function right here, and it uses the SimAuto command run script command, and the script command is to solve the primal LP. Actually, first it makes sure that the power flow can solve, and then it solves the primal LP. And then there's a procedure down here. If the checkbox is set for archiving system cases, then it'll execute the SimAuto command save case. So it tells it, where to save it and how to format the name. It's a derivative of the time point that it's associated with, and so on. Okay, so again, this is the user interface. This just explains where the data lives inside the access database that gets pushed into simulator, fixed generation, other parameters here. You can set, there's that checkbox for setting the constant hydro price, and if you do that, then it does stuff. So this is the general process that's in the code. Like we saw, there's a function for initializing the SimAuto connection. It reads in auxiliary files and stuff into an array just inside VBA so that it can grab the appropriate data at the appropriate time points. It uses the SimAuto function open case to open the case. Everything in italics here is a SimAuto function, and you can search through the code to find those. It loads the pre-simulation, the master auxiliary file, and then initializes tables for putting results in there. And then if you have if you have auxiliary files that get loaded at certain effective dates, It'll go through that table and check to see if there are any of them that are effective prior to the start date time that you select from the drop down, and if there are, it'll load those. And then there's a loop here for all the time points between the start and the end time. It'll load auxiliary files, it'll set generator megawatt values, and so for that it uses the change parameters multiple element function. If I wanted to find that in the code, I could just search for that. So yeah, here's there's a procedure for setting the generator maximum megawatts, and it passes in an array for change parameters multiple element for generators. A list of the parameters are the generator megawatt max field. The wind units have a maximum. It's passing in these fields and it's getting the vectors for those fields from the input table in the database. Okay, so it does that for each time point, and then of course you can click some of the buttons inside the form that'll open tables in Access and show some of those. And then that's pretty much it for the slides. So that's the B7 case. There's also a setup inside the form here that operates on one of the larger cases. It's based on the Eastern.pwb case that we've been working with in several examples, but it's the file name is actually Eastern DC, and we called it that because we set up the DC power flow in there, which works much better if you're doing this kind of process where it's cycling through. This one makes use of a filter. It's only going to retrieve results for generators that meet the area filter called study system. So it's not going to retrieve, we have those 3 or 4 fields that it retrieves for the generators, or maybe just 2 fields for each generator. Well, 4 counting the key fields. There's the bus number, generator ID, megawatt output, and the LMP at the bus. So those 4 fields get retrieved for each generator and for each time point. But we don't want to load, in a larger case where we have a smaller study footprint, we just, maybe want to pick some of those generators. So it's going to use that filter. And then for this one, I don't want to run, it's got like, I think a weekly series in here. It would take a while to run all those, but if I just want to run like 3 or 4 hours, I can click that. And it does the same thing that it did in the smaller example, except for we'll notice that things process through the message log a little bit slower because it's a larger case. Yeah, here it tells me that it's beginning the simulation for these 4 time points. And as it goes through, it'll solve each time point. And then we can do the same things as we did before. We can look at the results. We can go, if we're choosing, it's not archiving solution cases right here. So if I check that box, it would do that, but I didn't do that. But you could go back and then, again, play with the cases. So, and now it's done, and we could view results, and then we see same idea, except for there's a lot more generators. So if I want to, for example, look at all of the generators for this time point, all the records for this time point, looks like there's, 593. So we recall from earlier there were 593 generators in that study footprint in that case. And so it tells for all of them, this is the initial time point, all the outputs and the megawatt marginal costs. So anyway, that's kind of how that example works.
If you need further assistance, please feel free to look us up on the web, give us a call, send email to our support line, or if you prefer to work with a particular Power World engineer, please feel free to contact that person directly.